we did the long division. Synthetic division. I honestly don't have an answer of why it's called synthetic division, but we get to drop out the variables and we get to just work with the numbers, as I mentioned. Now, synthetic division will only work if you're dividing by something of the form x plus or minus a number. It doesn't work if it's a higher variable than or higher exponent than x to the first. It only works with x to the first. But, so, how we're going to set this up is we're going to have a box here. And that box is going to represent what we're dividing by. Now, we're supposed to be dividing by x plus 5, yes?
Yes.
So, I like to think about it as if we were solving x plus 5. So, if you had x plus 5 equal to 0, what would the x value be? Negative 5. So, we're going to put the negative 5 in the box. Okay? So, if they give you that factor of x plus or minus a number, you're always using the opposite sign, basically. Okay? Then, next to this box, we're going to put the coefficients of our dividend. So we're going to take what it is we're dividing into, and we're going to take the coefficients, the numbers out front. In other words, I'm going to drop off the x squared, the x, and the x terms. Now, just like long division, you might have to use placeholder zeros. Okay? So if x squared is my highest variable, then I want to make sure I have every x after that. So in this case, we have 4x squared, so I'm going to put a 4 to represent that. After x squared, I expect an x term. So now I'm going to put a 23. And then after an x term, I expect a constant, and that is negative 16. Okay? And we're going to leave basically a line of space for work, and then we're going to put a line. And that's your setup. Okay? Now, first job is we are going to carry down this 4 here. I'm going to carry this 4 down, and that 4 is going to be the first piece of my answer, because in the end, we're going to put variables back in. Okay? After I carry that down, that's my starting point. We're going to do a multiplication step. Okay? Multiplication says I'm always going to take this negative 5, my divisor, and I'm going to multiply. And we're going to multiply it by this piece down here. Negative 5 times 4 is negative 20. That negative 20 is going to bounce back up across the line, and it goes underneath the 23. And then we add. After you multiply, you add. What is 23 plus negative 20?
3.
3. Repeat the process. Multiply, add, multiply, add. So now, we always go back and use, in this case, our negative 5. This time we're multiplying negative 5 by 3. Negative 5 times 3 is negative 15. The negative 15 is going to bounce up and go under the negative 16. Okay, so negative 15 goes under the negative 16. What is negative 16? And then we add, sorry, what is negative 16 plus negative 15? Negative 31, yes? And you have your answer there. We have to put it back in proper form, but you have your answer here. In that, guess what negative 31 is? It's our, what always comes at the end? It's our remainder to our division problem. Okay, so you still can get remainders. In this case, our negative 31 is our remainder. And our 4 and 3 represent our quotient part of our solution. Our original 4 represented x squared, yes? Then we divided, think about it, if you take 4x squared and you divide by x, my exponent, my answer is going to decrease, yes? Because 4x squared divided by x is going to make this 4x to the first. And so the rule of thumb is this, my exponent here to start my answer is always 1 less than what it was in the original problem. Okay, so what I'm saying is since this was x squared up here, that means this is going to be x. And you continue your answer down from there. So this is going to be 4x. It's a positive 3. Well, after x, the first just comes a constant, doesn't it?
Yes.
So 4x plus 3. Do you remember how to do that remainder from Friday? Negative 31, or minus 31 over, now we're putting the x's back in. So it's over our original divisor of x plus 5. And that's your first synthetic division problem. This is synthetic division. Now, you want proof for that answer? Go back to our first long division problem from Friday. It's the same problem. Friday we did it long division, today we did it synthetic division. The 4x plus 3 minus 31 over x plus 5. Okay? I don't know if that's enough proof for you that it does the same thing, but it does. Huh? I'm going to say give it a couple more examples. I mean, there's a lot to learn, right?
Yeah.
There's a lot of pieces to put together. I think once you get the feel for it, you'll like it. Fair enough? Right now, it's just, you haven't seen synthetic division before, right? My knowledge, this is probably all brand new, because I don't think you guys do this in Algebra 1 at all. So, okay, you ready to try the next one?
Yep.
Okay. In the box. What am I putting in the box? Positive 2. My way to help you remember is think about taking x minus 2, setting it equal to 0. And so we're using the 2 as the representative value. After that box, we want our coefficients representing each term. My first coefficient is invisible 1, so 1, negative 14, 51, negative 54. Leave a little bit of room for work. Now, did I have any missing terms that I should have put placeholder zeros in? No, it went x cubed, x squared, x constant. It went in order. Okay, take your first value and drop that 1 down, yes? Then we're going to multiply. 2 times 1 is 2. And then where's that 2 go? Bounce it back up against above the line. After you multiply, you add. And this is where it is different than long division, isn't it? Because in long division you subtract. So this is multiply and add. That's all the steps we do. Negative 14 plus 2. Negative 12. And next, go back to multiplication. The original 2 times negative 12. 2 times negative 12? Negative 24. We're going to take 51 and negative 24, and we're going to add. And this is probably why I'm seeing the calculators come out. 51 plus negative 24 is 27. Then multiply again. 2 times 27 is 54. Negative 54 plus 54? 0. What is that 0? Okay. In this particular problem, we get a remainder of 0. Thoughts on how to express my answer? Because here's the deal. If you tell me your answer is 1, negative 12, 27, while I understand, I can't give you the credit, or I can't give you the full credit. Okay, take a shot, Paul.
X to the second minus 12x plus 27.
Yep. Paul, why did you start x to the second?
Because you have x to the third.
Okay. My original problem was x to the third, so go 1 less than that exponent, right? Here's another thought. If this is my remainder column at 0, can you work your way backwards? Remainder, 27 is my constant, negative 12 is my x. That makes 1 my x squared. Questions I should be answering. We're still just taking it all in. Okay. Two x to the third minus 7x squared minus 4 divided by x minus 3. What goes in the box?
Plus 3.
Okay. Since it's x minus 3, think of it as x equals 3. Okay? What numbers go in my top row?
2 minus 7 minus 1. Yeah, here. So you have to do the.
So we have a 2x to the third minus 7x squared, and what should come after an x squared? X to the first. Do we have an x to the first term?
No.
No, so we're going to throw in a 0x there. So if you throw in a 0x, obviously we don't need to write the x down, but we need to write the 0 down. And then negative 4. Placeholder zeros are hugely important in synthetic division. In long division, if someone wanted to argue I can do that without placeholder zeros, I'm not going to disagree. It is possible. Here, we need these zeros to keep our place values lined up, right? So placeholder zeros are necessary here. Okay, what was your first step? Bring that 2 down, and then multiply. So 3 times 2 is 6, and I'm putting that under the negative 7. What am I doing with negative 7 and 6? We're adding. What is negative 7 plus 6? He said negative 1, yes? Okay, what's our next step? Multiply 3 by your most recent number. So 3 times negative 1 is negative 3, and I'm putting that under the 0. Then we're going to add. 0 plus negative 3 is negative 3. Then we're going to multiply. 3 times negative 3 is negative 9. Then I'm going to add. Negative 4 plus negative 9, negative 13. Okay? Thoughts on the answer? To what? X to the second. So my original problem was x to the third. So decrease by 1 exponent. 2x to the second minus 1x minus 3. And then minus 13 over x minus 3, because x minus 3 was my original divisor. Okay? Is it getting a little easier? Get the routine down?
I like it better than what we did Monday, Friday.
I'm going to say, I'm going to be shocked if you say you liked long division better, but it can happen. Okay, one more. And then we're going to look at a couple applications. A lot of times on Savas, you're just giving your answers, but I know I at least saw 1 or 2 where you had to fill in the setup for the synthetic. So, okay, what goes out front? 1. Basically, you're always using opposite the sign, right? Okay, what goes after the 1? 3? 0? Negative 5? And 10. There's a 0 because what were we missing? We were missing x squared, weren't we? So that's why we had to throw in a 0. Okay. First step. Bring the 3 down. Then we're going to multiply. Multiply what? 1 times 3 is 3. And then we're going to add. 0 plus 3 is 3. And then we're going to multiply. 1 times 3 is 3. Then we're going to add. Negative 5 plus 3. Oh, something other than 3? What? Sorry. Felt very repetitive there. We kept saying 3 over and over and over. Okay, negative 5 plus 3, negative 2. Then we're going to 1 times negative 2, negative 2. And then 10 plus negative 2 is 8. Three, 3, negative 2, 8. What does that represent for an answer? 3x to the second plus 3x minus 2. This time it's a positive remainder, so I'm going to say plus. What does this 8 go over? X minus 1.
Everybody's favorite applications. Yay!
Okay.
Alright, what's the catch? No.
I got no catch for you right now. The synthetic division is that easy. Okay, it really truly is. So, okay. Let's look at the bottom then. One of the theorems that we talk about when we talk about synthetic division is the remainder theorem. Okay? And this is, there are times when it is helpful to just know what the remainder of a situation is. So this official language, if a polynomial p of x is divided by a linear divisor x minus a, then the remainder is p minus a. Okay? And the idea here that if you're dividing two things, once you know your a value, you can find your remainder pretty easily. A value coming from that x minus a form. Now, we're going to talk about two different ways to use the remainder theorem, or to find the remainder using the remainder theorem. Okay, so in example A, for the polynomial p of x and c equals negative 2, I threw c in because I think homework must have thrown c in. There's two things. We're going to be asked to find p of c two different ways. One by direct substitution, and one by the remainder theorem. Basically, we're going to try direct substitution, and then we're also going to use synthetic division. Okay? Unless Savas asks you to show work for both, it'll be your choice as to how you find the remainder in the homework. And on a quiz or a test, it'll be your choice. So part A, ask us to find P of C by direct substitution. Now, realize they define the theorem with A, but then they throw in C's in the problems. Okay? This asking us to find P of C is asking us to find the remainder. Okay, so when they say P of C, they're asking us to find the remainder. Direct substitution says, okay, if I want to find P of C, what is my C value in this case? Negative 2. Then what it says is I can take the negative 2, plug it into the polynomial. So plug it into that function, and once you plug it in, that will give you your remainder. I'll show you something to prove it here in a moment, because we'll talk synthetic division. But that's saying that I'm going to take negative 2, and any place I see an x, I'm going to plug in the negative 2. Okay? And I'm going to use specifically negative 2 because it didn't say like c minus 2, did it? It said c equals negative 2. So that means I'm going to do negative 2 to the third plus 8 times negative 2 squared plus 12 times negative 2 plus 5. Okay. What is negative 2 to the third? Negative 8. Negative 2 squared? 4 times 8, 32. 12 times negative 2, minus 24, plus 5. So you're doing negative 8 plus 32 minus 24 plus 5. Well, negative 8 plus 32 is 24. 24 minus 24 is 0. Plus 5 is 5. So, if we were to do the division, the remainder is 5. Okay? Now, the other way we can do this. It says by the remainder theorem. I feel like I should have just flat out said synthetic division. I have a feeling that Savas says the remainder theorem instead of synthetic division, which is probably why I did that, but when we do it this time, we're going to use synthetic division. Now, only one thing to watch out for here. When we set up the synthetic division, what's going in my box?
32.
It is specifically, or exactly, negative 2 this time. Right. If this was given as C plus 2, you would have to change the sign. But because it says C equals negative 2, it's that specific value. Okay, are we seeing the distinction? Because you have to be careful, because that's a really easy place to make a careless mistake. Other than that, the rest of this is the same. What values go after my box? 1, 8, 12, 5. Any placeholder zeros I need? No? Okay. Do the math. Drop the 1. Take the 1 and multiply. Negative 2 times 1 is negative 2. Put that under the 8. 8 plus negative 2? 6. Multiply. Negative 2 times 6. Negative 12. Add. 12 plus negative 12? 0. Multiply. Negative 2 times 0? 0. Add. 5 plus 0? 5. What's my remainder? 5.
So why do I have to do both ways?
More than anything, I'm just showing you it can be done both ways. I'm introducing both ways. On a quiz or a test or anything like that, I would not require you to do it both ways. I would say, pick what do you want to do. Okay? Are you more of a fan of plugging the value in to find the remainder? Or are you more of a fan of synthetic division? Okay? For today, my purpose is I need you to understand that both work. I'm showing you both. That type of thing. I don't care what you do in homework. Just do the homework. Fair enough?
As long as we get done, you care how we get done.
Well, that's not what I said, because that could really be interpreted a whole other way that we're not going there. Okay, let's do the same thing this one. We have a given polynomial, a given C value. It just says use the remainder theorem. I want to demonstrate both methods just for practice purpose. If you just want to do one on your notes, pick which one you like better. Okay? I'll be honest, I'm going to do my least favorite first. What am I going to plug into this polynomial? Negative 5. They gave me a C value right there. Does it say anything like C plus or minus a value? Or X plus or minus a value? No. So you're just using that C value. So we're going to plug negative 5 in. Negative 5 to the third plus 10 times negative 5 squared plus 29 times negative 5 plus 24. This is part of the reason I'm not a huge fan of this one. I'm going to have to pick up a calculator most likely. Synthetic division I can usually get away without the calculator. But To each their own, right? What is negative 5 to the third? Negative 125. Negative 5 squared is 25 times the 10 makes it 250. 29 times negative 5? 145. And then plus 24. I'm not saying I can't do this in my head, but it's not as easy. Negative 125 plus 250 is 125. 125 minus 145 is going to be negative 20. Negative 20 plus 24 is 4. Am I matching up with the calculator answer? I match up with my answer key, so. Okay. That's a great method. It works, right? If you ask me my preference, I'm going to say I'd prefer synthetic division, but you do whatever, if that's your preference, that's fine. Okay, if we check synthetic division real quick. What goes in the box? Negative 5. Next to the box? One, 10, 29, 24. Do I need any placeholder zeros? Cube, squared, first, constant? Nope. Carry down the 1. Negative 5 times 1. Negative 5. Add. 10 plus negative 5. 5. Multiply. Negative 5 times 5. Negative 25. 29 plus negative 25. 4. Negative 5 times 4. Negative 20. 24 plus negative 20. 4. Same remainder. Okay. You do you on this, okay? If you're ever asked to use the remainder theorem to find the remainder, I interpret it as either or. You can plug that value in. You can use synthetic division to essentially just divide it and ignore the rest of the answer and give your remainder. Okay? Now, we have one more topic here. Let's see. We pretty much, okay. Along with the remainder theorem, we usually talk about the factor theorem. Okay, so the remainder theorem, we find out whether or not there's a remainder. If there's a remainder, we know that it doesn't divide evenly. We know that this problem does not, this is not one of the factors of this problem. Okay? If there's a remainder of 0, which we've had happen, then it means that it does factor, and you're being given one of the factors. So this is the factor theorem. Okay? The binomial x minus a is a factor of the polynomial if and only if p of a equals 0. So that is fancy speak for saying that it is a factor if, what's p of a equals 0 mean? The remainder is 0. If you get a remainder of 0, it's saying it is a factor. Remainder of anything else? It's not a factor. So your questions in this type scenario says use synthetic division and the factor theorem to determine if x minus c is a factor of f of x. So on A, we're given this polynomial. We're given a binomial. We want to know, is x minus 4 a factor of this bigger function? Well, if it's a factor, the remainder will be 0. If it's not a factor, the remainder is something other than 0. So what am I going to suggest we need to do? Synthetic division. Now, could you find your remainder the other way? You could, and both would work. Bless you. But here's the deal. If they ask you to write your answer in factored form, you're already going to have what you need if you use synthetic division. Okay? So, synthetic division. What goes in my box? 4, because, so some of you identified, this is back in the form x minus 4, isn't it? So when they give you that form, realize, actually I think what I'm going to have you look at, this is x minus c, isn't it? So c equals 4. Okay, what goes next to my 4? Okay. 1, negative 10, 28, negative 16. All my place values are there again, aren't they? Okay. Do we have synthetic division mastered at this point?
Yes.
Okay. Do you like it better now? Okay.
Not this.
So drop the 1. 4 times 1 is 4. Negative 10 plus 4?
6.
I'm going to go with negative 6. 4 times negative 6? Negative 24. 28 plus negative 24?
4.
4. 4 times 4?
16.
Negative 16 plus 16? 0. So what is this 0? It is my remainder. And what does that mean?
There is none.
No, it means remainder of 0 means that x minus 4 is a factor. This can factor because when I divide it, there's no remainders. So remainder of 0 means x minus 4 is a factor. Okay? Now, if it works out to be a factor, my directions don't say it, but they're probably going to want you to write the polynomial in factored form. They're probably going to ask you for it. I'm going to want it. Okay. Now, factored form says p of x, this original polynomial, yes? What is one of the factors of this original polynomial? One factor is x minus 4. So, because what I'm basically doing is I'm going to take that and write it in factored form, but we're not going to do any of our normal factoring work. What's my other factor?
X to the second minus x. No,
So when I divided that polynomial by x minus 4, what was my solution? Or what was my answer? X squared minus 6x plus 4. So in other words, because if something factors, right, it divides into those two pieces. So if it divides by x minus 4, that means it's going to factor into x minus 4 times whatever the answer is, which is the x squared minus 6x plus 4. So there was an advantage this time to knowing, once you find your remainder, to already having the synthetic division done, because I needed that other piece for factor form. Now, is it possible they just let you answer, is it a factor or not? It is possible. I don't remember what homework asked, to be honest. Okay. Even though, no, I didn't look at this one last night. I looked at the next one. Okay, one more example. I want to know, is x plus 5 a factor of p of x in part B?
Yep.
Why? How do I decide?
Well, the first one was, well, no, the second one probably be no. Because the first one was yes, so the second one's going to be no.
Yes.
There you go. There's the teacher logic. I gave you an example of yes, so okay, the answer is no. Can we just skip it and move on to homework then?
Might as well.
Okay, how do we figure out this no? Synthetic division, what goes in the box? Negative 5, because this is in the form of x minus c. So that means it's in the form of x minus negative 5. Okay. Let's see. What numbers go next to negative 5?
9. 2.
2, 9. Negative 2, 6. Negative 40. No placeholder zeros, right? But you're checking. Okay. Drop the 2. Negative 5 times 2. Negative 10. Add 9 plus negative 10,
-1.
negative 1. Multiply negative 5 times negative 1, 5. Add negative 2 plus 5,
3.
positive 3. Multiply negative 5 times 3, negative 15. Add 6 plus negative 15,
-11.
I'm going for negative 9.
-9.
Multiply negative 5 times negative 9, 45. Negative 40 plus 45, 5. What do we know? There is a remainder of 5. So what does that tell me? Okay. Because it is, the remainder is not 0, then x plus 5 is not a factor. Right, you can't do a factored form. Okay, now, in my opinion, the hardest part of synthetic division is not messing up your signs, your adding, subtracting, the little mistakes you're hearing each other make, right? Be careful.
Thomas is very picky about that, so